DC biasing circuit. Biasing refers to the DC voltage applied to the transistor to turn it on so that it can amplify the AC signal. For the transistor to properly operate, it must be biased. There are several methods to establish the DC operation point. The first one is the base bias, emitter bias, collector feedback bias, and the voltage divider bias. There are 3 key DC voltage and 3 key DC currents to be considered. Note that these measurements are important for troubleshooting. IB stand for the DC base current, IE stand for the DC emitter current, IC stand for the DC collector current, VBE is DC voltage across base emitter junction, VCB is DC voltage across collector base junction, and VCE is DC voltage from collector to the emitter. Look at this circuit as 2 separate circuits. The base emitter at the left side circuit and the collector emitter at the right side circuit. Figure A is using the NPN transistor. Note that the emitter leg serves as a conductor for both circuits. The amount of current flow in the base emitter circuit controls the amount of current that flows in the collector circuit. Small changes in base emitter current yields a large change in the collector current. As discussed previously in the previous slide, the base emitter current changes yields the large changes in the collector emitter current. The factor of this change is called the beta. Beta is equal to IC divided by the IB, or IC is equal to beta IB. For proper operation, the base emitter junction is forward biased by the VBB and conducts just like a diode. The collector base junction is reverse biased by the VCC and block the current flow through its junction like a diode. Remember that the current flow through the base emitter junction will help establish the path for current flow from the collector to the emitter. Analysis of this transistor circuit to predict the DC voltage and DC current requires the use of the Ohm's law, Kirchhoff voltage law, and the beta for the transistor. Application of these laws begins with the base circuit to determine the amount of the base current IB. By using the Kirchhoff voltage law, subtract the 0.7 volt of the VBE and the remaining voltage is dropped across the RB. By using the Ohm's law, we can calculate the base current, which is equal to VRB divided by the RB. The collector current is determined by multiplying the base current by the value of beta, or the current gain.